right, this is number 5 from the 2016 FRQs. The first, we have this funnel here, and it says that the height, in other words, down here, the height is 0. Up here at the top, the height is 10. And the radius, the distance from here to here, is going to be this function of this length from the bottom to the top. And the key to this first problem is says find the average value. That's going to be average value theorem. So that's going to be 1 over 10 minus 0, the integral from 0 to 10 of this radius function, which is 1/20th times 3 plus h squared, and dh as the change in the height goes. dh is the change in the height moving vertically. So this is the formula that we want to solve. So the first thing you want to do here is take your 1/20th out with your 1/10, and that would be 1/200th integral from 0 to 10 of this function 3 plus h squared dh. And then we are simply going to do our rule. So we got this 1 over 200th out front, and then we do the integral of 3, we get 3h, plus the integral of h squared will be h cubed over 3, and we're doing that from 0 to 10. So we're going to have 1/200th out front, and we're going to stick in our 10, and then we're going to subtract, sticking in our lower bound of 0. And that right there is the answer. That's going to be the average value of our radius. The average radius from the bottom to the top is that length. Now, if you want, you could go ahead and simplify all of that. And if you do, which I've already done to save some time, this should simplify to 109 over 60. Okay, now this does not say that you have to do the units, but if you want to do the units, you should notice that the radius is in inches. So when we did this problem, this 10 minus deal here is inches. Okay, and then this would have been the change in the height is inches, and the change in the this part is also inches. So when you do this, when you do the multiplication of these, you get inches squared, but you're going to divide by that inches. So this would end up being inches again. So whenever you do an average value, whatever this measurement is over here, this part right here will end up being the same here. So the average radius is 109 over 60 inches. Then we want the volume of the funnel. So the volume is not going to be a lot different, except we no longer need this, right? And we are now going to be taking the area of our circles here. The area of our circles from bottom to top, okay? So it's still the integral from 0 to 10, and since we're doing the area of a circle, that is pi r squared. So we would need to stick a pi out here for the volume. And then we would need to take this as our radius. And we have to take the radius and we have to square that radius. So this is going to be the equation to find the volume of what liquid can go inside this. So by order of operations, we got to square this thing first. So when we square 1/20th, 20 times 20 is 400. And we square a binomial, you're going to get 3 squared, which is 9. You're going to take 3 times h squared times 2, which is 6h squared. And then you're also going to take h squared and square it, which is h to the 4th. That's a shortcut for a binomial square. And then we got this dh. So then again, after you square it, you're going to take this 400 out with a pi. So I would bring this as pi over 400, integral 0 to 10. And now we got to do the integral of this function. So we still got our pi over 400 out front, and then we're going to have 9h plus 6h cubed over 3 plus h to the 5th over 5, and we're going out again from 0 to 10. And now we're going to plug in the top one. So we got this pi over 400 out front, and we're going to plug 10 into all these h's. So we got 9 times 10 plus 6, no, actually, let's go ahead and reduce that 6 over 3 to a 2. So this would be 2 times 10 cubed plus 10 to the 5th all over 5, and then minus, we stick zeros in for all this, and to make this a little shorter, that's all going to be zeros, because this is not the exponent, so that's all zeros. So this right here would be your answer. Okay, so again, I worked this out earlier just to save some time. And you don't have, you can leave this as your answer. And again, this is volume, right? So this is inches cubed. But if you did solve this, it would be 2,209 over, and this is a reduced 40 pi inches cubed. And you can put that pi up in the top too. That's like 40. So that's part B. Then the last one, part C. Part C is a related rates problem. It says the funnel contains liquid is draining from the bottom. So this liquid, let's say it's up to there, it's coming out, there's liquid coming out right here. At the instant, the height of the liquid is 3 inches. So we're going to find this value when h is 3. The radius of the surface of the liquid is decreasing. So the radius is decreasing at this rate. So what that tells me is that dr dt, the change in the radius, is negative 1/5. If you want, you can put inches per second at this time. So we got that. At this instant, what is the rate of change of the height? So we want to know what is dh dt. That's what we're looking for. And that's supposed to be a question mark. When h is 3, that's the time that we want to look for this. So we need to take our function, and we need to take this function here, which is r equals 1/20th 3 plus h squared, and we're going to want to do the derivative of this thing, because we need to get all this stuff in there. So when we do the derivative of r with respect to time, we get dr dt. We always leave our coefficient out front. We do the derivative of 3, which is 0. And then we do the derivative of h squared, which would be 2h. And again, that's with respect to time. So just like this is implicit differentiation, you have to do your dh dt here with this. And now we're going to take all this information and we're going to plug this stuff up here into where it goes. So out here we get negative 1/5. And I would probably go ahead and reduce this and this. So we got 1/10. Now we're going to plug that h of 3 in here. And we are looking for dh dt. So we got negative 1/5 is going to equal 3/10 dh dt. So we're going to multiply each side by the reciprocal of 3/10. So we're going to take 10/3 on this side times this, which these reduce to 1. And take this side 10/3 times this, and these two will reduce this to a 2. So dh dt is going to equal negative 2/3. Right, negative 1 times 2 is negative 2 and 3, negative 2/3 inches per second. So in other words, at the exact time when the h is 3 inches, the radius is decreasing at 1/5, so it's going down. So see, your radius is getting shorter, but your height is also getting shorter because the height is going down as water's running out, and the height is decreasing at 2/3 of inches per second. Hope this helps. Have a great day, and I'll see you in class.